Everyone, everyone confirm?
Yes, Sudarshan, we can see.
Okay. Fine. See the variables.
Recording in progress.
Next we have is ADLV. So last class we discussed about ADLV and ABCM, right? So today we'll discuss ADLV and ADVS. Okay. So ADLV again it's a combination of your ADSL domain and laboratory domain, LB domain. Okay. So what we saw same previously, what are the variables we have in AD? We are taking from the ADSL level. So we will also take it here as well. Okay, so all these variables: study ID, unique subject ID, subject ID, site ID, country, birth date, sex, race, ethnicity, race values, age, race, sex, enroll flags, safety flags, planned treatment numbers, actual treatment numbers, treatment start date and time, treatment end date and time. Okay. So all these are direct variables from the ADSL. Okay. Apart from this, you have a new variables. We are going to take it from the LB domain. Okay. Same LB sequence variable is there. Okay. Sequence variables. So LB domain, LB sequence we have. So it's a direct variable. It's available in a LB domain itself. And if you have any reference IDs, LB ref ID. If you have data, reference IDs data available in LB domain, take it ADLB level as well. Okay. Next. Here, you won't directly capture the variable names. Here, see the terminology slight difference. Okay, we used to call param. Okay, param is nothing but parameter description. Parameter description. Okay. So if you take LB domain, LB test is there, right? So LB test will pass into parameter variable. Okay. Param code. Param code is nothing but same LB test code information will pass into parameter code. Parameter code. LB test code information. Same parameter category. Cat1. Parameter category. Okay. So LB domain, LB category information. So what is LB domain will capture? Mainly what categories of information? Can anyone tell me? What test we do it in LB domain? Mainly 3 categories, right? What are those?
Come with this hematology, biochemistry, all those things.
3 lab test categories to capture, right? One is hematology. Second is clinical chemistry. Third is urine analysis. Okay. So under each categories, you have a multiple test. So those test information will go to param variable. Test code information will go to param code variable. Test category will be the param code. Okay. Next. A while variable. A while. Analysis variable. A numeric character. 8 characters. So what is the variable you have? What is analysis value is nothing but results. What is the result information you have for a character numeric variable? Even though you have a character variable also, an analysis value in character. Here, eval is nothing but results. Okay. So we have standard results, right? Standard results in numeric data type, standard results in character type. So standard results in numeric data type will go to eval variable. Standard results character variable will go to eval serial. Okay. Analysis value, numeric and again analysis value. Next. Similar to analysis value, we have analysis visit as well. A visit number. Okay. Analysis visit. Analysis visit number. Okay. Analysis visit nothing but when the subject was visited, the visit information. Okay. So in LB domain, we have visit information already. LB visit variable. Visit numbers also we already derived. Visit numbers. Okay. So the terminologies are different here. The variable names are different here. Okay. Now, from the LBDTC variable, LBDTC is not about collection. When the particular sample was collected from the subject. DTC is nothing but date and time together will be there. From here, I need date separately, that is called ADT, analysis date. I need time separately, that is ATM, analysis time. I need date and time together in a numeric version, that is analysis date and time. Analysis in date. Okay. Analysis time. Analysis date and time. Okay. Everything was required in a numeric data. So already knows, right, how to take it the date alone from the LBDTC. Okay. What is the logic? Take the date part of LBDTC and then convert into SAS numeric version. We need to have time also. So take similarly take time separately, time part of LBDTC and then convert into SAS numeric version. Okay. If you have date and time, directly convert the LBDT into statistical regression. Okay. Okay. Next, ADY. Analysis the relative day. Again, relative day means a study day. How to derive the study day? Based on ADT variable and treatment started. Okay. But the formula ADY is equal to ADT minus treatment started plus 1. When ADT greater than or equal to treatment started. If it is less than, just do the minus. Okay. ADT minus treatment started. So this is a general variable. So this is the standard everywhere in every domain will be there. Apart from this, some important variables are there. To the next one. ABLFL analysis baseline plan. Yes, tell me what is the baseline plan? So LB domain we have already baseline plan. What is baseline plan? Remember what is baseline plan we discussed in LB domain?
Baseline is the first non-missing value of the analysis, like the elements like screening, whatever it is. The flag means yes or no, it will say.
Yes. The first non-missing test results we captured as a baseline values, correct? Test results for each test for each subject. So remember, right? So already in LV domain we discussed. So for example, some XX test we are doing, some LB test we are doing. Okay. So this test was during multiple visits. Screening week 1, week 2, week 5. Screening week 1, week 2. In every visit you will get a results. So in those results, the first result, the first non-missing test results, we are going to take it as a baseline plan. Okay. If you have missing value for this one, the next one we have to take it as a baseline plan. Now this is the ABLFL. Now same thing we are going to assign to the ABLFL. Okay. So now after deriving the baseline flags, now the real variables will come to the picture is the base values. what is the base value? Base value is this is a variable. If wherever the baseline flag is called yes, means at the time of baseline flag is what is the value of a value? That value will be the base value for a particular study, particular text. Why we are deriving the base values? To derive the change values, change from the baseline. So base is the one variable. We are going to derive based on the baseline flag. Again, change is another variable. We are going to derive based on the base values and a values. Okay. So if base is equal to not equal to null and eval not equal to null, the change is nothing but eval minus base. So what is this meaning here? So for example, some XYZ test we are doing for the particular subject. At the time of screening, we got a result of 256. So that is the base value we considered. That is a result. The first result we got is that's the base value. Again, we are doing the same test in a week 1. We got a 250 result. So what happened to the subject? Whether it was the result was increased or decreased, but change was happened. The change we are deriving. How can you know? How can you derive the change value? When you do it, eval minus base value, if you do it, you will understand the change value. See, there is a -6. There is a decrement was happened by 6 points. When I doing in a week 2, it became 260. Means there is an increment was happening 4 points from the base. The change I can observe. I need to observe the change. Okay, the change is from the base. How much was change was happening? Either incremented or decremented. To derive that one, first I need to derive the base value. From the base value, I need to derive the change value. Change is nothing but simply the eval minus base value. You get the change values. Clear? So everything was related, that's right. First, you need to derive the baseline flags. From the baseline flags, ABLFL. From the ABLFL base values. Okay. From the base values, change values. Okay. So here, if you observe eval is already available, ABLFL also you can assign. Base value at the time of screening is 256. Same 256 has to come for every subject. For this test alone, for all the subjects, it has to come. How to derive this base variable, base value? If you simply apply, if ABLFL is equal to y, then base is equal to 8. Eval, if you apply, what will happen? Wherever the baseline flag is equal to yes, those 56 numbers will come here. Then what about here? How to get the values here? Wherever the condition is satisfied, there you will get a 256. How you will do programmatically to get the base values for other tests also? So for same test for another visits as well. You got my question? If you derive base only properly, then you can deriving the change was simple. Because change is simply doing the minus. Eval minus base. So every observation it will check. It will do the minus. If you have a missing values, how it will do it? Correct? It won't check, right? You won't get any results. That's the reason. First base value how to derive properly. How to derive this base value correctly. Did you got my question, everyone? Someone help me in the programming. Tell me how to derive the base and change now. This is the data I have. This is the data I have. I need to derive this base value. This is my input data set. Here,
By using first dot.
okay, by using the first dot. Yes. What we'll do using first dot? We'll get the first dot values. Next. Okay, I'll give the code, okay? Use this code. Okay, let us assume so vital cell data set or LV data set. Next in the vital cells is also same thing you have to do it. Straight on or else in replace. This is my input data set, okay? XYZ MNO test we are doing. Okay, 256, 250, 260, 30, 300, 300, 320, 300. Now I need to create a base variable. It should contain 256, 256, 256, and 300, 300. Let's see how to do it. What I told you first, where are the base values to base? Those values will be the base values. Correct? 256, 300. So for example, XYZ set, 256 and 300. But I need to get here also 256, 256, here also 300, 300. Okay? To get like this, we can use a retain thing. Okay? So wherever the base value is not equal to null, okay? Not equal to null, then their base value is equal to base value 1. Create a new variable called base. If it is not equal to null, so keep the base value 256 value. If it is equal to null, okay? If it is equal to null, just take the old base values. Then use the retain function. When you use a retain statement, it will retain the previous value. Simple. And the code. The base variable is created. So what I'm writing the condition, first base variable I'm creating by writing this condition. Okay. If base 1 not equal to null, then create a base value as a base 1 only. Okay. If it is equal to null, assign to the base value. Same base value if you assign, the previous value it will retain. Why? Because it is retaining, because we are using the retain value. When you use a retain statement, it will hold that base value, the retain, it will hold the previous value, and it will come to the next value. That's what the base retain statement also will do. See, now your output got it. Then after this, you can derive the change value. What the change derivation I give? A base not equal to null, a value not equal to null, then change is equal to data. Data final one data set I'm creating. The final data set. So base not equal to null. See the change value I can derive now. If we keep the base values like this, you can't derive. It won't work. Now see, you can able to work now. 256 minus 256, 0. 250 minus 256 minus 6. 260 minus 256 minus 4. Again, 300 minus 300, 0. 320 minus 320, 305 minus 3. Okay. Clear, everyone?
Sudarshan, what is 0 there? Retain
Yeah,
base.
in the retain, okay, we have to assign some value at the beginning. Your retain at the time of starting, what is the base value? You want to retain, what is the retain value first time? When you're reading the first time.
256. Yeah.
No, when you're reading the first time, you don't know the value, right? How much you want to retain for the first week. When you're reading the first record, okay? When you're reading the first record, what is the base value you have to take it?
Okay. Oh, 0 is that value, right?
It's like initializing the value. For a base, you are creating one base variable and we are initializing the value as a 0.
Okay. After that, we are giving the if statement.
Now, after that, we are giving the base value. It is overwrites the base 0 to the 256.
Okay. Thank you.
Okay, and that same value it will retain when else come to the else statement. Okay. Remember this retain concept. Keep this code for reference. Okay, why I'm giving this reference? Especially I wrote it for everyone because in real time, in multiple places, it will be useful for you. Okay, you will get a scenarios like this. You will get a scenarios like definitely using first chart you will create same value you want come down. Previous value if you want to run, then use a retain. Okay. There is another programming also of there called lag function, I think. This is some advanced level. Okay. Lag function also it will be used. Okay. Maybe I was not giving an example anyway. Lag function also it will lag the previous value to the next value. Okay. There are not place for the exact giving an example. But just concentrate on the lag function. Okay. Lag function, what it will do? It will lag the previous next to the next value. For example, LB1 is a data set, right? Data from LB check data set and pairing. Set LB2. Eval1 and pairing. Applying the lag function. Let's see what happened to the how the values will come. It is lagging the next value. So 256, it will come to the 256 like this. 250 will come to the 250. Okay. So 256 is coming to 250. So it is lagging one value below. 256 to 256, 250, 250, 260, 260. Okay, this lag you can turn, you depends on the requirement, you can use this lag function. For example, maybe you have a requirement like that. What is the change was happened to the previous test was it? Due to the previous test and correct test, what is the change was happened? So that time you can use this one. Okay. Again, you have to write a first dot, okay? First dot of each test. First dot of the test. Then I'll do the lab. First, you need to sort it. Okay. It is lagging the previous, this value it is lagging. Okay. Okay. So basically understand it and try to do it some other logic. Not working for this data. Just I want to give awareness about the lag function. It will be useful in real time maybe. Okay, clear? Just simply use a lag function, it lags to the next value. Okay, so whenever you get a situations like this, you can use the lag function. Okay, so concentrate, you can practice on a couple of data also if possible. Maybe in your given project if you get it or not. Okay, concentrate on this lag functions and this retain statements. Okay, keep these codes as a reference. Okay, maybe in future if you make it, you can just refer and we'll get an idea what to do. Okay, fine. Clear, right? First of all, this one, how to get the main one? How will we derive the base values? Okay. Here, any questions, anyone? Let me adding your notes as well, so it will be useful for you to reference. Here, any questions? So now you understand what is the baseline path, base values and change values. Now, this change values you may have to derive in a different ways also. Depends on your study. Maybe my study, current study, for example, change one. I need a change from baseline at study day one. Day one means wherever the day ADY value greater than 1, then only derive the change values. See, if ADY greater than 1, then change value should be eval minus base value. I need a change from baseline at day 10. Between 1 to 10, what is the change was happening? So if ADY greater than 1 and ADY less than 10, then your change value should be eval minus base value. Okay, clear? So like this, study specific variables also will be there. So apart from this, we have few more variables. See, analysis normal range lower limit, normal range higher limit. So we have in LB domain standard result lower limit, higher limit among variables. You can assign to this one. Apart from this, there are direct variables also. Predecessor variables are available. LB test code, vaginal unit, standard direct data type, numeric data type, standard units, toxicity grades, visit number, LBDTC, lab names. These are predecessor variables. Direct variables in the LB domain, we are bringing into ADLB level. Okay. And apart from this, some study specific. For example, I need a analysis flag, analysis record flag. I need a 2 flags where there, for example, wherever the ADY greater less than or equal to 1, give the flag as yes for one variable. If it is greater than 1, give the flag as another variable, give the flag. Okay, these are study specific variables. In your study, you may have a tables. Okay, wherever the ADY greater than 1, you have a tables. So to get the tables, to create those tables, we are creating the flags here itself. So there, to create the table, I use this variable directly. Instead of this derivation, instead of doing this derivation at a tables level or listings level, we are doing here only. Okay, like this study specific variables will be there. Okay, and this is a direct variable, LB, NR, and reference range indication. Like you have indications low, medium, high, normal, or abnormal. Okay, so these are the direct variable from the predecessor variable from the LB. Clear? That's it. So these are the variables you have in the LB domain. ADLB. Okay, see the specification also. I think specification you have very less variables comparatively here. See, study ID, unique subject ID. These are all ADSL variables. Study ID, unique subject ID, site ID, SAR, age, race, sex, flags, plan treatment, actual treatment start dates, end dates. And apart from this, see sequence numbers, reference IDs, parameter categories, parameter codes, parameters, A value, LCs, indicator, base values. That's it. Up to base only you have. Apart from base, you can refer the note. Okay, we have base values, change 1, change 2. Okay, analysis flags. Yeah. So this is ADLB. Now ADVS is so simple. Now it's clear, right? Any questions, anyone here in ADLB? Here ADLB was clear, ADVS was simple. Instead of LB, it is VS. Same type of variables will come instead of LB, VS. Same variable, parameter categories, evals, visits. So here it is clear, right? LB, ADLB, especially these derivations, baseline derivation, change derivations. Okay.
So Darshan, like I have a common question here.
Yeah.
So, like SDTM, is there any like if we derive all the variables from the specifications, or do we need to remember all this and we have to derive all the variables that you listed here?
No, you will get a specification. The same way you will get a specification. The specification, what are the variables you have in Adam level? Those variables only you are going to derive in Adam level. How you are deriving now in SDTM level? Same way.
Okay.
Okay. But you don't have proper specification. You don't have full-fledged specification was not there. Okay. I am giving in the notes some extra variables. These are common variables.
So, but regarding that, yeah. So we from the specifications we can know the variables that we have to derive, right?
We
so
have to derive. From the specification,
logic and everything it is fine, but yeah.
From variable you get. No need to remember the variable names, okay? So need to remember the variable names, all the variable names. It's highly impossible to remember all the variable names.
Yeah. Yeah.
Correct? Very impossible. Yes. The specification is not remember the logics. That's it. Okay.
Yeah.
Some important variables will be there. Baseline flags, base value, change value. These are important. For interview point of view, it was required for it.
Okay, sir. Thank you.
See now ADVS. Now ADVS is so simple. What we discussed in ADLB, same thing. It's your ADSL again, VS. Okay, now whatever we discuss now, same thing will come here as well. Just instead of LP, it should be VS. Because in Vitals, different test will do. First of all, in ADSL related variables will take it, in ADVS as well. Okay. Next, vital signs variable. There are predecessor variables, VS sequence, reference IDs also there. Here the parameter values, but the test, we are doing the different test. Vital signs will do height, weight, temperature, body mass index, okay, systolic pressure, diastolic pressure, these type of tests will be. So the test values will go to param variable. Test code, test short names will go to param code variable. VS category values will go to param category variable. Okay, eval is nothing but analysis values. So standard is numeric versions, character version. Character version will go to eval C variable. Numeric version will go to eval variable. Again, baseline flag derivation same. In Vitals also we have derived the baseline flag. So simply the test will change here. Here your tests are like weight, body mass index like this. Okay. So 101 subject at the time of screening. What is the test? So we are giving assigning the baseline flag. Run the baseline flag. Again, we have different visits there. A visit number. Okay. Maybe in your study, if you have A visit derivation was like this. Generally, the standard derivation should be in VS domain. What are the visit values? Visit number values is there. Assign those values. No, in my study, specifically they asked, okay, where are the baseline flag is called? Yes. By default, the derivation that's the visit should be baseline, irrespective whatever it is there. Maybe, for example, the derivation was the the visit value may be week 1, but don't Keep it as a weak one, keep it as a baseline. Even if it is a screening also, make it the visit as a baseline and visit number as a 0. If baseline flag is equal to S and set is equal to 0, when visit number. Assign the visit number as to 0. In the previous all the cases, assign the respective visit values from the vital signs domain. Okay. In only wherever the baseline flag is equal to yes, set the values. It's a study specific. In your study, if they want to represent the a visit number, then apply this logics. No, in my study was not required. My study they're asking to assign the visit value means assign the visit values. LB domain and vital signs domains. Respect to visit number directly variables are there, you can assign those variables. So they want asking in a specification they were mentioning was like this, then you write a derivation for this. Okay? Then same. VSDTC also you have collection date. From collection date you can derive date separately, time separately, edit. Date and time numeric version. Okay? So take the date part of VSDTC and convert into SAS numeric version, you will get the ADT. Take the time part and convert into SAS numeric version, you will get ATF. Convert a VSDTC itself into numeric version, you will get ATF. ADY is equal to analysis relative date, same standard formula based on ADT and treatment start date. Again, same baseline derivation. If baseline value is equal to yes, then assign take those base values. Take the base values and you can derive the change values as well. Okay. Again, base derivation already I gave and change derivation also. Previous in LB domain, what we discussed, same derivation will applicable here as well. For baseline derivation and the change derivation. Change is nothing but change from the baseline. It's a value minus base value. If they want change in a different time points, change 1 and change 2. Change from baseline at state 1, study day 1, change from baseline at study day 10. So simple, if the ADY greater than 1, eval minus a base value. If ADY greater than 1 and less than 10, eval minus base values. On different time points, in different days, we are deriving the change values. Apart from this, all these are predecessor variables, standard variables. Test code, original result, unit, standard is a character data, numeric data, units, visit number, DTC, visit name. Okay, these are all predecessor variables. Already available in vital signs domain, we are taking here. And apart from this, any study specific variables, flags if you have anything. Analysis record flag 1, analysis record flag 2. So simple, if ADV in ADVS domain, if ADV less than or equal to 1, give the flag. If greater than 1, give the another flag. Create another variable, create another flag. Okay, so you don't have any new variables in ADVS when you compare with ADLB. Same variables, whatever variables we discussed there, same variables, because only the test will change. Okay. Clear? Anything? That's it for we have for AD, LB and ADBS. That's it we have for Adams as well. Okay. So these are the Adam data sets we have, and tomorrow we'll discuss the tables and listings. Okay. Okay. Any questions or anything? So that's total 5. ADSL and we under VDS category 2 domains, under OCGDC category 2 domains. 4 plus 5. Okay. So that's it I have done today. So tomorrow we'll freshly start tables and listings. Okay. Any questions, anyone? If nothing is there, finish stop it here.
Recording stopped.
We'll continue tomorrow. Okay.
Okay, sir.
Yeah.
Okay, sir. Thank you.